These are the notes on heat transfer. As we start to talk about heat and energy in this unit, let's get through or look at a couple of definitions. So, thermochemistry is the branch of chemistry which studies the transfer of heat between chemicals, which is usually what we call the system, and the environment, which we call the surroundings, during a chemical reaction. So the notes that you have will have blanks for where you are needing to fill in that information. Feel free to take other notes as you need. So, what is the difference between temperature and heat? Well, temperature is used to measure the average amount of kinetic energy in a system. Kinetic energy is the energy of motion for anything. So when we're looking at temperature, it's the energy of motion of the particles. And individual particles will all have different amounts of kinetic energy. And so with that temperature, it is the average amount present for all of the particles. If if a chemical has a higher temperature, that means those particles have more kinetic energy. They are moving more quickly. So temperature is a measure of kinetic energy, whereas heat is the flow of thermal energy, heat energy from one object to another. And heat always flows from a high temperature to a low temperature. And so, one thing on the practice is kind of looking at modeling that flow of heat. And so, if we have something with a high temperature, that heat is going to flow to the lower temperature object. And so, let's say this, for an example, this is the stovetop, which would be hot. And then if you have a pot of water, maybe you want to boil some water to make pasta, that stovetop is going to get warm. That's going to have a high temperature. And then that is going to transfer that energy to something that has that lower temperature, that pot of water. And that is how our water would heat up. If we wanted to kind of model temperature, anything with a high temperature we're going to show a dot for the particle, and then we just have some longer arrow to show that there's that higher amount of kinetic or motion energy. Something with a low temperature, we would still have dots, but we would have smaller or shorter arrows there. All right, so we talked about kind of a system heat flowing. Um, between a system and its environment, the surroundings. A system, and we can define systems in many ways. A system is the definition of a system is kind of that part of the universe that we want to focus on our attention on. And then we can classify everything else as the surroundings. And especially in chemistry, we're going to kind of focus on the system being uh, the particle that is experiencing that energy or that temperature change. When we get to things like, or when you get to a course like physics, we kind of play with that definition of a system based on what factors we want to consider or what things we want to kind of ignore for the time being to make our problem a little more simple. And so the part of the universe that we're focusing on is our system. If we have an open system, and if we're kind of talking about heat or mass being particles, if we know if we have particles that go from liquid to gas, we would be losing mass. An open system is one where energy and mass can be exchanged. And so that idea of boiling a pot of water, that would be an open system because that energy is being exchanged from the burner to the pot of water. And so that would be an open system. A closed system is where only energy can be exchanged, so mass is going to stay constant. We are going to be looking at closed systems kind of throughout this unit because we're not going to look at how mass is changing. We're going to just be looking at that transfer of heat. An isolated system is where something or where nothing is going to be exchanged, so no heat or mass is entering or leaving the system. That's not going to be useful in our purposes. So we're going to define most of our systems to be closed. in this um, in this entire course, but specifically in this unit as we talk about heat. So, exothermic reactions, let's define what those are. You've probably heard of them before. So, an exothermic reaction is a reaction where heat is released. And so that's being released from the system. And so it would go into the environment. And that means that heat is a product in that type of reaction. Some examples: the dissolution, the dissolving of sodium hydroxide in water is exothermic. So the NaOH is the system dissolving and releasing energy to the water, which would be the surroundings, causing the solution to get warmer. And really what's happening is the water is getting warmer from that dissolving of a solid. And so we would see heat on our product side. And again, we can kind of model this using arrows to show heat leaving the system in something like an exothermic reaction. The reaction between aluminum metal and copper chloride solution from our limiting reactant lab earlier in the year, that was a release of energy. We could have measured the energy using a thermometer, but we did not. But you should have felt your solution get warm in that case. And so again, heat would be on our product side. And then any combustion reaction is an exothermic reaction. And so we would have those hydrocarbons plus oxygen producing CO2 and H2O, heat being a product. Endothermic reactions then are the reverse, a reaction where heat is absorbed by the system. So it's kind of that substance that we're focusing on in that problem. And so heat would be a reactant. And so dissolving or dissolution is not always an exothermic reaction. Sodium chloride in water is an endothermic reaction. And so when that salt, which we would define as a system, that solid sodium chloride dissolves, energy is absorbed from the water, which is the surroundings, causing the solution to get colder. This was seen in the salt truck lab. It did lower, or the freezing point of that solution got lowered. But if we're looking at the reaction of just the sodium chloride dissolving, that one we should have seen a decrease in temperature in our data, kind of a little right away. Whereas with our other salt, calcium chloride in that lab, that was an exothermic salt. And so that's why the calcium chloride kind of bumped up, whereas this one would have only gone down in temperature. And then an Alka-Seltzer tablet added to water absorbs the energy of the water. When we did our stoichiometry lab, we saw this reaction. We didn't really measure heat, but maybe you noticed that the solution was getting colder because heat was being absorbed. Heat was a reactant, taking that heat from the surroundings and entering the system. And so we use arrows to show the heat entering the system if we wanted to just model what that would look like. All right, so enthalpy of reaction, this is probably a new term to you. Enthalpy is a very complex topic, and we're going to look at a fairly simplified understanding of it for our purposes this unit. All chemical reactions require some amount of energy to occur. And so chemical bonds require energy in order to break apart. And then when those break apart, energy is released. And then energy is released when those bonds are created. Depending on the reaction, the process may overall have a release or an absorb of energy. If we look at how do these values compare to one another. And so the energy released or absorbed in a reaction is the enthalpy of reaction, or that is more commonly called delta H. And so that energy being released or absorbed. So heat is that transfer of thermal energy. And so we can kind of see this heat in a reaction if we are looking at comparing now energy values. And so we're not going to see that delta H in our reaction, because that enthalpy of reaction is an energy value. Um, if it's an exothermic reaction, because energy is being released, our delta H is going to be negative because we are going to have kind of that loss of energy throughout the process. In an endothermic reaction, heat energy is absorbed, and so that means that our energy or enthalpy of reaction is going to be a positive value. So a lot of kind of new vocab um, in this unit. So looking at this enthalpy of reaction summary, if you would like, feel free to pause the video, try these on your own. So we want to just highlight what is the appropriate answer for each question. So exothermic, I think exit. So energy is flowing out of the system in an exothermic reaction, which means if energy is flowing out, our heat is released, meaning heat is going to be a product. And then when we're looking at that, well, what does that mean about our delta H? We have that exothermic delta H is negative. That release means that our final energy is going to be lower than our initial energy was. So exothermic and exit energy is being released. Endothermic energy is flowing into the system, meaning that heat is absorbed and heat is a reactant. And so, because we are going to kind of have that going into the system, so it's going to be the energy is built into what products get made. And delta H is going to be positive. All right. There is a enthalpy of reactions or a heat transfer worksheet for practice. Please reach out to your teacher with any questions.